on my end that the recording is started. All right, it's started. So good afternoon. I am Csabatóth from GDG Fresno and Women Tech Makers Fresno. And this is the third part of our Android 11 series. Today, we're going to speak about modern Android development. So what is modern Android development? You might have a little deja vu feeling hearing this, because if that's true, you might seen this same title in other major conferences. Like here you can see the Android Makers, April 2018. Then it was also Devoxx France, which is a big Java conference, Google I/O 2018, Android Developer Summit 2019. I'm pretty sure if we wouldn't have a pandemic, there might have been also here 2020 Google I/O, some presentation about modern Android development. But since the pandemic, we will have now a virtual presentation. To transition to modern Android development topic, first, let's talk about classic Android development. When these modern Android development presentations were held in 2018 and back in the time, the practices and tools presented were modern for their time. Looking back from today, we can think about them as classics. They served their purpose to help Android become the global leader in native application development. However, many of the solutions left much to be desired, to be honest. And time is passing by extremely fast in the technology industry. We're going to go through a short history lesson about where we have been and what changes led us to be where we are today. This glimpse of a timeline shows some major changes related to both API, then some tools like Android Studio, language changes, Kotlin, or libraries like architectural components. Talking about past, the language was Java only. It provided a type-safe and robust memory management alternative for developers to enter the mobile development world. On top of that, Java as an established ecosystem provided ample amount of libraries and patterns, not to mention that it's free. So there are a lot of tools and even IDEs which support Java. The whole ecosystem was extremely healthy, so many libraries. Talking about tools in the past, I already mentioned the IDEs, integrated development environments. What you can see here is Eclipse with the so-called ADT plugin. ADT stands for Android Development Tools. Eclipse is a free open source development environment for Java. Whoever was already a Java developer, or actually, I have to correct myself, it's not just for Java. You can do C++ and other languages as well. So a lot of developers were familiar already with Eclipse. And Eclipse has as an open IDE provides opportunities to add various types of plugins. For example, ADT is a bigger set of features added to it. So basically, you took that popular IDE and like put a clothes on to be an Android development platform tool for you. Now, how about the APIs? Back in the past, There were very frequent releases, and that's what's great. There were regular bug fixes, but sometimes these bug fixes weren't fixed. Earlier APIs problems weren't backported. The whole platform was in its early phase, if we look back from 12 years. And we're going to see that this improved significantly over the time. So if you are just paint the releases, later the updates slowed down to down to a yearly cadence. But back in the beginning, it was very it was much more frequent, which wouldn't be a problem if everything would have been backported. Let's just say a few words about distribution, how we distributed our apps. That's the classic way of APKs. These are basically zipped content for our convenience, for the size of the packages. What if you have more configurations? Then either you have more APKs at the same time, or your APKs gets bigger. So in the previous slides, we introduced the basic facts for classic tools or solutions and reasons behind the language and distribution. And with the following sections, we will talk about problems. So first, language. Java programming language. It's very nice, well-established, great, but sometimes it's too verbose. About tools, Eclipse, many people liked it, but for Google, it was hard to customize because it's such an environment that it, as I mentioned, it's not necessarily just Java. There's C++ and other languages supported. It also supports enterprise Java development, a lot of different, very different goals than Android. Some subtools tended to have inconsistent UIs, and so Google had their own internal problems, and what they probably saw that there might be other IDEs which are more liked by the majority of the developers. Now, APIs. As the whole platform exploded and basically became the lead, and this platform is much more permissive and open than Apple's other ecosystem. There can be so many devices that the fragmentation came into picture. Not just API fragmentation, but there were so many different types of devices, different configurations, different hardware. So this needed to be addressed, and the bug fixes and all the adjustment had to be more uniformly covered. Now, things like lifecycle or storage and navigation alone can be complicated by nature. Let's look at the fourth topic, the distribution. We mentioned APKs, and they are monolithic. So as I mentioned with the fragmentation, there are so many various devices. There are ARM devices, there are MIPS devices, x86 devices like Asus had a phone. So all of these had to be packaged up into one monolithic big package and distributed to any device, even if they didn't need that architecture or that kind of resolution of assets. So that was a problem as well. We'll talk about that later. But actually, starting right now, the answer to the problems is the modern Android development. So again, what is modern Android development? It's, I would say, basically Google's advised and provided best practices to us for us as developers to be productive, create better apps, and enhance the users to be happy with our apps. So modern Android development, we could say it sits on 4-pillar foundation. We already divided actually the classic portion by these 4 topics: the language, the tools, the APIs, and the distribution. And we will look at each one by one now as from the viewpoint of modern Android development. So again, the language, the modern development is using Kotlin instead of Java. What is Kotlin? Let's look at the short history of Kotlin. The version 1.0 appeared in 2016. Just a second, I look at if somebody wants to enter, because I heard a chime. It sounded like somebody wanted to enter, but I don't see anybody. All right, then let me get back to the presentation. So Kotlin, the 1.0. By the way, now that I am interrupted, if you have any questions, feel free to interrupt me, and I will answer you. Okay, I heard a chime. Maybe somebody is asking in the chat. I'm checking.
Yeah, the message was saying that if we're still waiting, so I think we need to let this person in.
Oh, yeah. Okay, I am just replying to him. I am recording. So let's continue. Yeah, maybe this was him then. I heard the chime. So this Kotlin, basically, the Java as a language runs on a virtual machine called JVM, and any language which is able to compile to the JVM instruction set is a JVM language, and basically could function as well as Java. For example, Kotlin is one we are talking about, but there's another language called Ceylon, which is developed by Red Hat, or if you like functional programming, there's Scala or Clojure. The Java ecosystem is very colorful. Kotlin is one of the alternatives for Java on top of the JVM. And when I say JVM, by the way, Android itself has a very specialized version of JVM, which is also evolved over the years, so Dalvik and Art. But I just wanted to give you a little background of how this Kotlin comes in. Kotlin is not that much different from Java. It's nicer, but it has also extra features we'll see. So back to this timeline, Kotlin appeared in 2016 with the first version. Then developers started to use it, and Google officially started to support it and announced it at the 2017 Google I/O. But sometimes still some certain portions broke for those developers who used it. It was upsetting for them. But over the years, it became more and more mature, more and more embraced by Google, and all the way until it became the prioritized first-class citizen over Java. That's what we call Kotlin first. And so that doesn't just make Kotlin very stable for Android developers, but it improves the development. We will see later. Many new APIs, what Google develops, are now developed first on Kotlin and then later ported to Java. Examples like paging free, coroutines for Room, WorkManager, and there are more training examples and documentation are created by Google for Kotlin. So it's now the first class citizen, and even now the so-called coroutines are preferred, and we are here today. But still, why Kotlin? Kotlin is very expressive. It means less boilerplate code you have to write. The type system is strongly typed, and nullability is baked into language level, which helps tremendously with safety. It works seamlessly with Java, so interoperability is great. You can usually even Android Studio offers conversion back and forth. Obviously, if you use some Kotlin specific feature, then the conversion is harder. It's easier to migrate to Kotlin from being a Java developer and use your skills you already have. And it's easy to upgrade existing projects to Kotlin. And about the concurrency, I already mentioned coroutines. Those are a form of concurrency. There's very elegant asynchronous programming, and it helps a lot to avoid the dreaded callback spaghetti. Let's look at actually code examples. I love code. So what do we see here? We see that bundle, which has this question mark there. That's how you signal nullability for this bundle typed variable. That means that we can catch a lot of errors, nullability related errors, build time, and they won't be a runtime null pointer exception, which is a dreaded thing, very common. Let's talk about lambdas. They are shorthand syntax for anonymous functions, and they are very concise, and they help to avoid the callback hell. They are succinct and readable. I would say if you see this code, I don't have the Java equivalent, but it's much more verbose. You would have a not much more, but more verbose if you use already the Java lambdas. Anyway, let's look at also extension functions. They make helper code more discoverable, and they have fixing API problems in a compatible and release agnostic way. So you can see the capitalized there on that string. And we also see template expressions. They are compile time checked expressions inside of a string. It's way easier and more succinct than formatting string in Java. We also see here getter setter, that properties are built into the language, and so there's no more confusion between private and public fields and public getter setters. You might see similar features in other modern languages. It's great that Kotlin has this. It's just more succinct. Why else Kotlin? One reason is speed. Now, I'm not necessarily talking about code speed, but the speed of how fast you develop your application, or also how fast a language is evolving. Google and JetBrains are constantly improving the language and the runtime library. Coroutines were experimental last year, and now they are fully supported. Flow for supporting streaming values are in now, and they are supported. And extension methods allow many features to evolve outside of the language too. So it's you are not you feel that the features you need, they are coming at you when you need them. And also developers seem to like it well. So if we look at the statistics, 60% of pro Android developers use Kotlin. 70% of the top 1,000 applications contain Kotlin code. So it's well liked. And some examples of how Google is working to improve Kotlin support. There's lint checking. There's a dedicated compiler team, specific optimizations, and they are working on things like annotation processing speed and similar. The annotation of the platform APIs, they catch bugs at build time, so they won't be a runtime crash. These are, for example, the recently nullable, recently non-null, or the nullable and non-null type annotations. They have with all of that. Also, more and more so-called Kotlin extension libraries are available. They are constantly improved. Sometimes when you have a specific library you are including for your classic Java native app, often you have a KTX version. So when you upgrade your project, you can use these KTX versions and take advantage of the Kotlin features. Take a look at another example. In this case, we're gonna trying to create a bitmap in our application. So we have the bitmap API. We want to draw it onto a canvas through this drawable. And here's the application code which achieves that. So we are setting the bounds, then we are creating the bitmap, then we call a draw to the drawable, which involves a canvas class, and then again we set back the bounds, the old bounds, what we saved in the beginning with this is also a language feature here, what we can see here, this unpacking. Now let's see, drawable KT has this extension function on drawable. All right, how does this help us? And poof, this is the little one-liner now, what we need. This 2-bitmap extension function does what we want. I guess we can agree that this is pretty nice. Also, maybe other initiatives. I think I mentioned before Room and WorkManager. The coroutine specific APIs, they make asynchronous programming really smooth, and the use cases become much simpler. The paging tree is a complete rewrite of paging in Kotlin. It also includes coroutines. And for example, Jetpack Compose, that's a completely new UI toolkit for Android. It's a new way of composing UI versus the old XML-based declarative way. This is a code-first declarative way of composing, and it pretty much reminds me of Flutter way, but that's not Flutter. We are talking about native Android. It's pretty nice. You may have heard the last couple of several weeks about it because they had announcement and they reached milestones, and now it's really testable. And I predict that might be a big way of composing UIs in the future, preferred over the other existing ways. Check out the website, the developer.android.com/Kotlin. I will include that, I think, in our meetup. I already posted this slide deck, and I will include that URL. Google has a lot of documentation, training, samples. I love the code labs because that's where you can start to tweak one of the code labs. You pick the code lab what is closer to what you want to try, and then just start to tweak them and play with them, and you will get accustomed with them. There are courses also, and there are articles and videos. Let's talk about modern Android development tools pillar. This brings the power of IntelliJ. It's great for code and writing and refactoring with built-in capabilities for Android. IntelliJ was one of the three major Java development environments beside Eclipse and NetBeans. And so what Google picked up is that developers liked, usually the pro developers liked IntelliJ better, and so they embraced it. And now that's since 2016, I think that's the first class tool for development. Oh, here's the history lesson. Yeah, here comes our timeline. I ran a little bit ahead with this. So it was, I was wrong, not 16. Yeah, it was announced that it's here in 2013. And then for a while, Eclipse ADT was still alive, and you had both. You had the choice of either using Android Studio or Eclipse ADT. Obviously, in the beginning, Android Studio wasn't as mature, but over the several years, it matured and became the first-class citizen. And maybe that was in 2016. Maybe I'm wrong. I was right, but you can see that around 2017, you can see the signal that the constraint layout editor of Eclipse ADT was deprecated. So that was already a signal that Eclipse ADT is going to go away. And so Android Studio 3.0 came on 2017 autumn, and Kotlin support came. A lot of improvements with CPU, memory, and network profilers. Then D8 is now a default compiler for DEX code. DEX code is basically, this is connected to the virtual machine I was talking about. So you have to compile the Kotlin code down to that virtual machine. There are more profilers like energy and system trace profilers. Graphics tool to create, edit, and view flow through application screens. And that's the navigation editor. Simpler way to do find view by ID. It avoids overhead of other approaches. Recently, visual creation of powerful UI animations with which uses motion layout. That's with the motion editor. That's also a pretty nice feature. So Eclipse is an open source IDE which has to cater to dozens of more scenarios, whereas Android Studio is Android specific and tightly integrated. And it allows powerful code refactoring, extensible UI feature tools. The integration examples are like navigation graphic tool and templates. We mentioned the motion editor for motion layout. And I would also add, so I'm listing also here, I won't read those, but I would also add, if you followed Android Studio, how much the Android SDK management, so upgrading and installing API versions, platform versions, tool versions, or the virtual device manager improved. It's more integrated now, easier to handle. And hopefully this will continue on and it will be even better and better. Speaking of APIs, Android Jetpack is the third pillar, what we talked about, or the APIs are the first pillar, but the majority of work is done by Android Jetpack. And the modern Android development relies on it pretty much. The APIs now are unbundled and can be used across releases. So remember that back in the day, some stuff weren't backported. And team of engineers at Google are working on, if there is a new feature or bug fix, they often go back to prehistoric years like Android 5, like ice cream sandwich and stuff like that, which is pretty crazy. Kudos for those engineers. So we're gonna only talk about part of Android Jetpack because it provides so much functionality. I will just show glimpses of what it can do. Now, in 2017, a constraint layout was appeared as version 1. That was one more powerful layout compared to the earlier layouting techniques. Then architectural components appeared. So if you see this, I intentionally don't show this more zoomed in because I don't want you to pay attention to the details. Probably you've seen these state graphs, how the activity or either the fragment lifecycle is going on. It can be complicated. And also, if you are from a developer perspective, you want to preserve some state, then how are you going to do that? If somebody just simply rotates the screen, your activity will go through, will be rebuilt, like destroyed and recreated. So that's just crazy. And fortunately, architectural components came to the rescue and provides stuff like view model, where finally you can sanely preserve states between, for example, those screen rotations or other very common problems like roomies for SQL-like light database data storage stuff. So lifecycle and these problems can be overwhelming. But Jetpack provides solutions for that, for example, fortunately. Now, similarly, paging and navigation or background work or foreground work can be very daunting. And Jetpack, again, provides solutions for that. Material design components, they are around for many, many years now, but Google put in energy and a lot of time to make it even more appealing. So it means that it wouldn't be that every material design app would look like the same. It's easier to pick colors and take advantage of all the all the research of what these UX experts put in to design how the click and other actions react on the buttons and etc. Those are really, really well researched. Jetpack embraces that. If you have dealt with cameras, especially with Android's versatile ecosystem, some phones have 5 different lenses, one for macro, one for wide range. So that's a hard topic, and the developers who had to deal with that had a hard time. Unfortunately, the Camerax API is an awesome API. We will actually see an example for that. We'll see that. And I already mentioned the motion layout and motion editor. That's an amazing for animations. So Jetpack, let's talk about some layouting. So constraint layout, we could say that that's a relative layout plus enhanced. You can build a rich UI with the interrelationship between the different views on it, including nice constraints. Subclass of constraint layout transitions from start to end states with the ability to customize the animation, tight integration with tools. So you can see the motion layout editor here. That's here. You see a nice animation. We talked about I mentioned Lifecycles. Sometimes, if you have had any interview about Android development, they were asking you what comes after on start, and I don't know what comes after on stop, and the fragment is even a little more complicated than this. But this with Jetpack, I don't say you can forget about this, but it's much easier to deal with the pain points of Lifecycles. For example, one way to deal with that is back in the past, you had the app compat activity, and you had to override these functions, which were called. Now, this is not the case anymore with Jetpack. What you have is so-called lifecycle owners. The app compat activity and the fragment itself are lifecycle owners, and you can get a lifecycle object and then set an observer on it. That's what we see here. And then once that's done, the observer can implement any of the lifecycle events and can also query the lifecycle state at any time. So I think that's a little nicer than the previous way of doing this. Another feature of Jetpack is the view model. That the view model stores so-called LiveData objects, and these can be observed as well. This helps to separate the data from the UI. So here you can see that activities and fragments they observe our data, and then the changes then send to those UI elements. And then meanwhile, the data layer talks to room and some other data objects like network or probably via repository it talks to. So at the same time, data can be persisted as well here to a SQLite database through Room. And Room is also part of the Jetpack support. We can query for example, the list of items. Here is a data access object. It's the DAO. And either you can have standard insert, delete, or update functions, or you can have some custom query, what we see on the top with the get all. And it's really smooth now, much less code than it was before. One more thing, sorry. If you see here the suspend function directives, it means that these are coroutines, and you can handle them asynchronously. And this is already built in. That's very useful when you don't want to block your UI, which is probably all the time. You don't want to block your UI. So this helps a lot. Also, there is paging library, which can talk to room and return a page list object instead of all of the objects. And this is all in Jetpack. There's so much more functionality available in Jetpack, including new project templates for navigation. And these all, since all of them are part of Jetpack, they work well together. The view model LiveData are both lifecycle aware, so this is to avoid any leaks. So all the features are nicely working together. Coroutines and flows are Kotlin concepts for handling incoming data or data which is changing constantly. So it's easy to, with coroutines, have these off the UI thread. And Google also knows that you might have a bigger code base which deals with this. All of what I said with RxJava. RxJava is an older method to do event-based programming, and also you are doing asynchronous all of these operations. And so before Jetpack and Kotlin coroutines and ways, that was the way we were doing these. And this is also still supported. And so don't worry if you have that, that's fine. So it still works. So the new studio, there's a new template which makes it easier to create applications with navigations built in. There's a nice user interface to design navigation transitions, for example, fragment to fragment here, and the template by default creates two destinations with actions going between them. Right, this is all right inside the Android Studio. Here is the underlying code, the XML declaration for this navigation graph. Now the code to navigate to the destination, including swapping fragments out and doing the right thing with the backstack, is trivial. That's the code. So I guess in the past, if you have done that, it required more. So this is really neat. Some addition to this navigation, safe arguments can be passed. And I think for a while now, the advised way to design your application is single activity, and you have fragments within that you are navigating between these fragments. Provides, if you follow these best practices by Jetpack, it provides proper consistent up and versus back handling. And also there's support for dynamic features. I also so we are still talking about Jetpack features. I also talked about WorkManager, or mentioned it, sorry. So what is this WorkManager? Back in the past, there were several different ways. Like Firebase had its own background worker thing. Google Play Services had some stuff, and there were at some point 4 different ways to tackle this problem. If you want to perform some kind of computation in the background parallelly, or some deferrable work, and basically, so this is basically WorkManager, which is for deferrable work where timeliness is not as important. For example, you want to upload some analytics data in the background, but it's a guaranteed background work, so it is persistent across device or application restarts. To ensure backward compatibility, it's compatible back to API level 14, which I looked up, and that's ice cream sandwich back 2011 October. We can agree that that's pretty old phone if you have such. But sometimes you might come across such users. The engineers did the work and backported it. WorkManager abstracts underlying framework support on older versions. And so like in Android 6 or above, they use the job scheduler. Before that, they use the alarm manager broadcast receiver. That's the implementation detail. It also supports periodic tasks or chained sequence parallel tasks. And on top of that, you can have constraints for the execution. What are these constraints? Here, for example, when you are filtering the images, that can be very CPU intensive. So then you can add the constraint that don't do that task until the battery is charged enough. Don't do that task if the battery is too low. Then compression of the image, that's somewhat CPU intensive, but it also uses disk I/O. And so don't do that if the storage is too low. And finally, when you upload the whole result, don't do the upload if you are on an unmetered network. And these are all these green dots are constraints. Here, what you can see. How this looks in the code. Here we can see filter worker. That's the first step of the filtering. You can see that it derives from the worker class. And what you have to do is implement this do work function. Of course, what we see here is Kotlin. You see that fun and override. Now, you do the filtering. And sorry, you have to return. This is the way you return the result or signal to the framework if you were successful or not with this filtering job. Now, you can, once you've done that, you can chain these different work processes. So, for example, this was a photo beautification, let's say. And for each task, we will add constraint optionally. What we have seen here, I mentioned for the actual filtering, we set the battery not low constraint, and then this is the way we are first creating the constraint object, and then we set that constraint to that filter. And then there can be other work requests as well, which may have other constraints. We may see that later. We are following what we saw on the graph where we had 3 filters, and here we add this to the WorkManager, So it would do those filters, and we enqueue those tasks. Sorry, all right, it disappeared. And then you can see also the chaining here. So once, gosh, I want this to go away. So once the processing of the filters finished, then you can see the then. So then compress and then upload. It's also very, very readable. What back in the background, what we deal with is future, return values, and asynchronous programming. Very well readable. I love it. It's very concise. And so basically we enqueue these different filters with different constraints and kick them off. And the WorkManager will take care of the rest. It's very declarative. There's also foreground service support. For example, yeah, it's you want to use these sparsingly because the system tries to keep them alive, and there's battery implications. But I've heard stories that certain phone manufacturers tend to kill off background tasks a little too much. So if you run into that, maybe you have to resort to that, but try to avoid foreground service. Here's an example, by the way. So that's an example for a foreground service. So a worker that uses the coroutines API provided by WorkManager. Do work is again the suspend. Do work is the suspend function you have to implement, and you bind the worker's lifecycle to the foreground service. And so you should also supply notification information, similar to how you would set up a foreground service using a framework API. So here, how this goes. You invoke the logic and then return the results, and that's it. Very concise and neat. I also mentioned on that timeline, if you remember, of the Jetpack, the Camerax API. The Camerax works with 94% of the Android devices back to API 21. API 21, by the way, it's Android 5.0 Lollipop that goes back to 2014 November, so more than 6 years ago. They backported this. So it gives a great coverage. Those who have worked with the camera features know how painful it can be. Different devices may have different camera characteristics, and the Camerax API provides an abstraction to common tasks. They call them use cases. And the Camerax handles the camera lifecycle for us. So if you haven't worked with the older APIs for camera, you might not know how nice is this, but I think even without that experience, we can agree it's going to be really nice. You will see. So let's see the standard use cases. First, you just want to preview what you're going to later take a photo of or handle. Then you might do some analysis or processing of the image. Also you can capture image. These are not necessarily in this order, obviously. These are main use cases here. And the image analysis. The preview allows the app to have a viewfinder that shows the live camera feed. The analysis give you the access to the camera frames, so you can get the bytes and run your algorithms against it, which enables features like object detection and augmented reality. The capture use case simply allows you to take a picture and save it to the disk. So let's see some code. Here in step 1, we create and configure an image capture object. You give it a config object, and in the config, you can specify parameters like a resolution of the picture. There is a challenge here. Users love Android for its device diversity, as we talked about. However, as a developer, it can be difficult because the parameter works on one device might not work on another. Camerax handles this diversity for you. For example, if the device doesn't support the resolution, or it conflicts with other use case running at the same time, Camerax will choose the second best parameter. The configuration will always be successful. Now, the second step is the binding. There are different lifecycles in an Android camera app: the lifecycle of activity, the lifecycle of the camera, the capture session, and many more. By binding the use case to lifecycle owner, Camerax will take control of all the lifecycles, so you don't have to manage the state machines yourself. The camera is opened when it's needed and released when it's done. Now the step 3 is the action. Last but not least, the interaction. Once it's set up, you can start using the use case. If you call take picture, it will snap a picture. With 3 lines of code, you will have an image capture pipeline. What you see here, pretty neat. So let's close off this long API section, where we once again only saw just glimpses of what Jetpack offers to us. Google is always very busy doing new stuff here. Expect new additions, enhancements. And if you are curious about any of these features I mentioned, like the Camerax, there are dedicated separate sessions on those code labs to explore more. Now, I mentioned that there are new releases. You don't have to worry about this because everything is backported, and there are right now new APIs in development, like the recent Compose UI. And I didn't even talk about Hilt, which is a dependency injection framework. You can find dedicated sessions on that. We mentioned the paging free, which is Kotlin first developed. So we all have that. Let's talk about the last pillar, the distribution. So we don't have to resort to APKs anymore, monolithic APKs. There is a so-called Android app bundle. Let's again take a look at history. Android app bundle launched on the 2018 Google I/O, and let's say, why do we need Android app bundle? We know that 3 out of 10 phones have less than 1 GB of internal space. That's pretty stunning. At the same time, the constrained storage leads to uninstalls. So users without free storage are almost twice as likely to uninstall compared to users with free storage. So meanwhile, the larger the APK, the more likely it is to have issues with installation. So APK size, app size matters. Yet again, on the other hand, the data shows that smaller downloads mean more installations for an app. So everything points towards smaller for you to try to minimize the size of your application. Now, app bundles achieve the smaller installs by only downloading the config data needed for just that particular device. So what we see here is each Android bundle contains high resolution, extra high resolution, low resolution, extra high resolution assets. If you have language support, you have all of these language support assets. Then with the blue color, you have the various chip architectures. And what, fortunately, with the APK, all of this, regardless, let's say you have an x86 device, you would still get the ARM and the the ARM 64 architectural components, and you don't have any use for it. And also, you probably would have 3 unneeded out of the 4 different resolution types. And so what happens is that you give this ability for Google to be able to chop up your APK. Actually, you don't even upload an APK in this case. You build this AAB, what we saw on the previous screen. That's the that's how we call it. And then they're gonna do this job for you, the App Store or the Play Store, sorry. It analyzes what's going to be the device which wants to install it and only gives what is really necessary for the device. So here's what I talked about. It's called dynamic delivery with a nice graph. And so if we think about like assets as the green, so each device only gets what it really needs. And the good news with this is that you don't have to do anything for this. Just instead of APK, build an AAB, upload that to the Play Store when you are releasing your app, and everything else will be taken care of by Google. That's all. Yeah, just what you build, and you will get that benefit. And by Google statistics, the developers uptook that, and 35% of the active installs use it. Nearly 50% of the top apps and games use bundles. And in general, bundles decrease the size by 20% if you are comparing it to monolithic APKs. And once again, every advantage what you can get for free, I would say you can get this for free. It's worth taking. So let's put all of what we heard together. We have seen the 4 pillars: language, tools. We see Kotlin. For tools, we saw Android Studio. For APIs, we had a smorgasbord of Jetpack features. And for distribution, we saw the Android app bundle. Now, of course, there's even more to that. These were just glimpses. Check out the modern Android development page, and you can get more details of each of these. So with that, we arrived to the end of the presentation. Thank you for listening. Let me know if you have any questions.
I do have one question.
Yes.
So for developers like me, spend most of my time debugging code. So what kind of debugging capability in a modern tools?
Debugging, Google enhanced the profiling features. So the way you are profiling memory, CPU load. I don't have that much experience with that because I am arriving with my games to that point. But like regular debugging, that's like standard. That, for example, stepping over functions and having the local variables. That's not an improvement. That's just something what you expect from IDEs. What can be an extra is how well you can do performance profiling. That's like performance profiling is a more advanced debugging, or also there is development related to release debugging. So one hard problem is once you release your application and it's out on the Play Store, when it is crashing, because it's gonna crash, I can tell you, on user devices, you will get back the stack traces. You in the Play Store you have you get pretty detailed data about what kind of devices crash, what is the exact stack trace, and that's not strictly Android Studio but related stuff, but I know that that's also constantly under development to make that the user interface better, less clunky, easily accessible, so you can navigate. I was navigating between crashes even on my phone, so you can do that on your phone as well. You still need to do a jump between the crash on the Play Store to your source code, but even if I think I have warnings that there is not enough symbolication information, like because with release versions you might remove that. I could still have the line numbers, and I could debug, so go back to my code and see where it's crashing. So that part is it's nice, and I'm pretty sure that 12 years ago it wasn't that good. So over the years and I know that they are still trying to improve it. So expect improvement there. Also, if we are talking about performance profiling, it's not just CPU, but if you are working on a game, for example, there's GPU involved there, and that's really hardcore when you are going to that level that you are debugging GPUs. But I think there are some tools as well. I haven't used them, but yeah, that's what I know about debugging.
Awesome, thank you.
No problem. All right, I'm reading what Jake writes. Modern architectures. So as a beginner who just finished his first Android bootcamp, I sometimes feel lost, not knowing how to pick an architecture for a project. What are your thoughts on modern architectures? I feel you, because I have that problem sometimes. So when you have to start from a high level and think about what are your goals with your projects, where do you want to end up with, what are the whole projects, what does it need, what kind of capabilities. And then usually what I do is I try to find example code, like either existing open source projects which kind of sort of cover my use case, or code labs which kind of sort of cover my use case. With code labs, what you get is sometimes where you have to add a lot of code, like you have to be careful to handle all the error conditions. So you have to polish it really well, but at least you get some kind of starting point. If it's not a code lab, but a real world open source existing project that
Hi, the person you're about to speak with has call captions turned on. They'll see captions of what you say to help them listen along.
I just got a notification for the system. So when it's an existing open source project, usually I have the inverse problem that it's not polished enough, but it has some extra features I'm not gonna need, so I rather need to chop off stuff. So that's about finding some starting point. But then about architecture, it's really yet again, you have to think about again the features of your project. So if your project's gonna be a GPS heavy, it will use GPS a lot, then try to find a project which has GPS support in it, and then I would try to find such a project which is very well maintained, and this would mean that hopefully it uses the latest technologies. Because let's say with GPS, I wrote a GPS application not so long ago. I talked about RxJava, so try to already use, now that Kotlin is the first class citizen, and I talked about coroutines and flow and streams. Try to find a project which uses that, or example codes, because that will guarantee that later you won't have to go through maintenance tasks when you have to convert RxJava to streams or stuff like that. Because I already have this problem that I already picked a project which is Kotlin, but there's still a little RxJava in it, so I'm gonna need to have some tasks when I have to convert that to newer Kotlin and newer code. But in general, whatever code you write, you probably run into this, that time to time you have to transition to newer and newer technologies. Hopefully, if you don't leave yourself behind too much, then those transitions will be smaller steps. If you don't do such maintenance refactorings, then it can become bigger. What I would advise is to start from, when you are starting, try to start from the current modern best practices. So you already would jump through some generations of refactorings and would start from the current. Now, where you can find that, there's no central place to find it. If you are, maybe there's one more. So I mentioned that trying to find a code lab or existing open source project like on GitHub. There's maybe even one more way if you use the templates. So Android Studio provides a lot of versatile templates for certain scenarios, and you might be able to start from that. In that case, you won't have to deal with cutting off that much extra functionality if you would pick up a bigger open source project, but that's also a way. You can quickly just look into those templates if there's anything which covers your scenario, and compile it, see what it does, and see if it's enough. If you just have to extend it a little bit, or sometimes your idea is a mashup, then you can do multiple projects, look at each of them, and then you have to do the mashup manually. But I always like to analyze existing applications to start off. I know that it's since the scene is evolving so fast, it's easy to run into a project which doesn't use the latest best practices. So that's why you have to look at possibly multiple one and pick the one which is the heaviest and most maintained, and also knowing which are the latest technologies, what some of it you heard of, then you can decide which is the best candidate for you. There can be many other factors too. I don't know if this answer was good for an answer. I don't know. It's a very good question. This is very hard to make the first step, and it's important what you choose to go from. Are there any more questions? All right, I think I will stop the recording.